See, today we have to start here the relation between delta H and delta U. See, the relation between delta H and delta U we have to see in last lecture. Delta H is equal to delta U plus P delta P. Then for the chemical reaction we have to study here the relationship between delta H and delta U. See, for the chemical reaction we have to study here that solid and liquid phase, there is that change in volume, it will be the neglected term for the solid and liquid phase. But in gaseous state, that volume it will be the changes. That's why we have to write here the equation delta H is equal to delta U plus P. Delta V means V2 minus V1. Then we have to write here in terms of delta H is equal to delta U plus P V2 minus P V1. Then we have to use here the ideal gas equation that PV is equal to nRT. Then we have to replace that PV is equal to nRT, that nRT for PV2, that PV2 is equal to N2RT and PV1 is equal to N1RT. Then we have to put out that PV2 and PV1 in that equation. Delta H is equal to delta U plus PV2 minus V1. We have to replace that delta H is equal to delta U plus that N2RT for PV2 minus N1RT for PV1. Then delta U plus M2 minus N1, that same term we have to carry out, that RT as a common. Then delta H is equal to delta U plus delta N for gas phase. Because solid in liquid, that change in volume it will be the neglected, but in gaseous state that will be the change. See, we have to get the equation delta H is equal to delta U delta N for gases, that will be N into RT. That equation derived as for the 2 marks. Then second, the work done for a chemical reaction. Work done for a chemical reaction. We have to know that the pressure volume type of work equation W is equal to minus Px into delta V. Here the Px, external pressure, is equal to the pressure of the gas or to consider. Then we have to write that equation W is equal to minus P delta V. Then for gas phase, that will be the change P V2 minus V1, V2 minus V1. Again replace that ideal gas equation nRT. PV is equal to nRT, then N2RT minus N1RT. Delta N, that W we have to get the equation for the chemical reaction, work done minus delta N GRT. At delta nRT we have to get reaction for chemical reaction, that work done it will be calculated. Means this is the two relationship in delta H and delta U and work done for the chemical reaction. Then here the two conditions that N2 is greater than N1, that delta N is positive and work it will be the negative, that is the work is done by the system. When N2 is greater, work is done by the system, that W is a negative one. Then if N1 is greater than N2, that delta N it will be the negative, work it will be the positive, that will be the work is done on the system. Work is done on the system. For the condition that N2 is greater, that work is done by the system. When N1 is greater, work is done on the system. Then the next term we have to study here the enthalpies of physical transformation. Enthalpies of physical transformation. Say, physical transformation we have to write here enthalpies of physical transformation. Physical transformation. See here, they have classified in the 3 ways. It will be for the phase transition. Then a second is the for ionization and molecular changes here, that molecule. And third is the for the solution or the solution. Here the in phase transition there are again 3 types. That will be for the first process for fusion, second for vaporization and third for sublimation. Means the enthalpy change in the physical physical transformation. First is the phase transition. Here the ionization and atomization. Ionization and atomic state conversion. And here for the solution, that will be the lattice enthalpy they have calculated. One by one we have to study here the enthalpy in physical transformation. First, fusion. Fusion means the enthalpy of fusion. Enthalpy of fusion, that will be the enthalpy change that occurs when 1 mole of solid, it will be converted into liquid. 1 mole of solid, it will be converted into liquid. What to call the enthalpy of fusion, and that will be denoted by letter delta FUSH, fusion. And we have to take an example of water. Here the example of water, H2O, that will be the ice in solid phase, that will be converted into H2O in liquid phase. That delta fusion, that delta H value, it will be get here, that will be the plus 6.01 kilojoule per mole at 0 degree Celsius. That will be value for the fusion process. Then opposite to that fusion, liquid is converted into solid, that will be the freezing point we have to call here. Then opposite that delta H value, it will be the negative. Then second term is vaporization. That will be the enthalpy change that will be occurs when 1 mole of liquid, it will be converted into gaseous state. 1 mole of liquid converted into gaseous state, that at constant temperature and pressure, we have to call as the enthalpy of vaporization. Then that enthalpy change that occurs when liquid will be converted into a gas phase. Liquid, it will be converted into gas phase. That will be the vaporization. VAPH denoted. Then that reaction water liquid, here that water liquid, it will be converted into the gas phase. That will be called in water liquid in a vapor phase. The delta H value, it will be given at 25 degrees Celsius and at 100 degrees Celsius. Because we have to know that the water, it will be boils at 100 degrees Celsius. It will be calculated at 25 degrees Celsius. That value, it will be given at 100 degrees Celsius is 40 kilojoule per mole, and at 25 degrees Celsius it will be 44 kilojoule per mole. Then opposite to that vaporization, it will be goes to again that gas vapors, it will be again liquid phase, that will be the condensation process, means that value, it will be opposite to that. Then the third is the sublimation. Means solid, it will be converted into the gaseous state at constant temperature and pressure. Means enthalpy change that occurs at constant temperature and pressure from solid to the gaseous phase. Means here the two steps, that will be the first solid to liquid, liquid to gas, we have to combine, and delta sublimation we have to calculate it. Delta H for sublimation means first solid to liquid, liquid to gas. Then addition of these two terms, that will be the fusion and vaporization is the sublimation. Fusion and vaporization is the sublimation. Means the enthalpy of sublimation, that enthalpy change that occurs in when the 1 mole of that will be the solid directly converted into vapor at constant temperature and pressure, we have to call it as the enthalpy of sublimation. Then here the second type, that will be the enthalpy of ionization. Ionization means here, let's take an example of sodium, that will be converted into Na plus by removal of an electron. Means the enthalpy change when remove the electron. Enthalpy change when that will be removal of an electron from 1 mole of the gaseous atom, you have to call it as the enthalpy of ionization. That sodium they have used 494 kilojoule per mole, that will be the for ionic formation, that Na converted into Na plus. Means the enthalpy change that will be accompanying removal of an electron from its 1 mole of an gaseous atom. That will be. Then second is the atomization. Here that will be found here the Cl2 in gas phase, it will be converted into Cl and another Cl. Means at atomic state, they have molecular state converted into the atomic state, that atomization energy for that, and that will be for given for the Cl2 delta H value for atomization, it will be 244 kilojoule per mole, Then again electron gain enthalpy, like a removal of, then electron gain enthalpy opposite to that, atomization, that will be atomic state it will be formed. And last is the solution, that will be for the NaCl example. That solution, last enthalpy for the enthalpy in a solution they have given for the NaCl. Given for the NaCl, that will be converted into the Na plus and Cl minus ions, that will be converted. Or they have given the for the solution, that aqueous solution NaCl in aqueous solution, that NaCl in solid phase. We have to add the aqueous solution, that NaCl solution it will be prepared. That solution it will be prepared. In that there are two steps must. First they have forms the ions. They have formed the ions. म्हणजे Na plus and Cl minus ions तयार होतात. And in second phase they have converted into hydrated. म्हणजे काय की Na plus हा hydrated आणि Cl minus हा hydrated. Hydrated complex तयार करतात. काय तयार करतात? Complex. And then they have calculated the enthalpy change. That will be the enthalpy for the solution. It will be the enthalpy for solution. Enthalpy for solution. It will be equal to the lattice enthalpy plus hydrated enthalpy. That is the formula they have used for the solution. They have used for the solution. Today we have to stop here.